Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we'll look at quantifying errors. Quantifying just means put into numbers. So we're going to calculate the size of errors here. So there's three types of errors: absolute, relative, and percentage errors. Why do we need all three? Well, the absolute error just tells you the size of an error. It doesn't tell you how big that is in comparison to the scale of the question. That's what relative and percentage errors do. So for example, let's say you are measuring the length of a football field and it's supposed to be 100 meters. If you were off by 1 centimeter, that's not really a big error. 1 centimeter is tiny compared to 100 meters. But of course, if you were supposed to, say, measure the length of a cell, which is in nanometers, being off by 1 centimeter is a massive, massive error. And that's why we have relative and percentage errors. They tell you how sort of big or small the error is in comparison to the scale of the problem. So let's look at this question here and calculate some errors. A person ran 100 meters in 12 seconds. Their time was recorded as 12.06 seconds. We're going to calculate the absolute, relative, and percentage errors. Let's start with absolute error. So note these weird lines here. They mean absolute value. Your absolute error should always be positive. This is just saying if you get a negative value, just change it to positive. So in this case, the absolute error is just what was measured, 12.06, minus the actual value. So the absolute error here is just 0.06 seconds. So that's the absolute error. That's pretty easy, 0.06 seconds. Now we're going to calculate these two, which will give us an indication as to the size of the error. Is it a big error or a small error in the context of the problem? So the relative error is just going to be the absolute error, which we calculated as 0.06, divided by 12, the actual value, the actual time run here in this case. And so the relative error here is 0.005. The percentage error, you just take the relative error, which was 0.005, and times by 100 and stick a percent sign on the end. So it's 0.5%. So again, the absolute error just tells us the size of the error with sort of no context, whereas the percentage error tells us how big or small the error was in the context of the problem. This is just telling us that the 0.06 seconds by which they were out, by which the time was wrong, is very small in comparison to the 12 seconds. It's only an error of 0.5%. All right, let's now look at another question involving errors. So here we have a cylindrical bottle of Coke supposed to hold 600 mils of liquid. Its height is 15. We're going to calculate the percentage error of the volume if the radius is 0.2 centimeters too large. So let's first figure out what the radius should be. So when we're talking 600 mils, mils is a unit of capacity, so we're talking about volume. The volume of a cylinder is pi r squared h. So we're finding the radius here. So we've written the formula step 1, good. Now we're going to substitute everything we know. So we know the height is 15, so I'm replacing h with 15. We know the volume is 600 mils, which is 600 centimeters cubed. So I can just put that in, 600 centimeters cubed. So dividing each side by 15, I get 40 equals pi r squared. Divide each side by pi, then square root. This is what the radius should be. So that is about 3.5682. That's what the radius should be. So if the radius is 0.2 centimeters too large, that means the radius is going to be this plus 0.2 centimeters. That means the bottle of Coke, its volume would actually be pi times 3.7682 and so on. So this would be the actual volume. So when I'm putting this on my calculator, I want to keep this. So this would be on my calculator already. I want to call it again by using the answer function. So what I do is I add 0.2 to this, so just go answer plus 0.2, then I'm going to square this number here. That takes away any rounding errors. So I square that and times it by 15, also times it by pi, I get 669, or about 669.14 mils. So that means if the radius was 0.2 centimeters too large, we'd actually have an extra 69.14 mils. So the absolute error would be 69.14. That's how much extra Coke would be in the bottle. We divide that by the amount it's supposed to be, 600. And then that's the relative error. We times by 100 and stick a percent sign on if we want to find the percentage error. So again, I've only written 69.14 here. But what I'm going to do in my calculator, after getting this answer, I'm going to go answer, the answer button, divide 600 times 100. And that will reduce the errors. So putting that in the calculator, we get about 11.5%. What does this all mean? This means that if you were making Coke in these 600 ml bottles and the radius was just 0.2 centimeters too large, a tiny bit too large, your container, your bottle of Coke would have 11.5% too much Coke. Alright, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.